Hi everyone, this is Math 6, Lesson 1-1. Fluently add, subtract, and multiply decimals. In this lesson, we'll be able to add, subtract, and multiply decimals. Let's start with solve and discuss it. Maxine is making a model windmill for a science fair. She is connecting a cardboard tubes together vertically. So vertically is up and down. Horizontally is left and right. Each tube is 0.28 meters in length. What is the combined measure of the connected tubes? So if you can see in the picture, there are 4 tubes, the cardboard tubes that she's going to connect. I drew a diagram here. If you connect them vertically, you're going to connect them from top to bottom. And each of them is 0.28 meter in length. So combined total would be 0.28 plus 0.28 plus 0.28 plus 0.28, which is also represented as 0.28 times 4. So altogether, it's going to be 1.12 meters. So in the diagram, you will see that you have 2 boxes, big boxes of grid line. Each box contains 100 little cubes inside. So each box represents 1 meter. And so you're going to shade the whole thing to represent 1. And you're going to color 12 cubes on the next graph. So that is 10 cubes and 12 because you know that 1.12 is equal to 1 plus 0.12. So this is represented as a graph. Okay, look for relationships. Suppose that Maxine made another windmill model by connecting 4 cardboard tubes that are each 2.8 meters long. What is the combined measure of this model? What relationships do you see in the factors you used here and above? Explain how this helps you solve the problem. So what is the combined measure of this new model if each tubes are 2.8 meters long? So you would use the same method except you would have 2.8 plus 2.8 plus 2.8 plus 2.8 instead of 0.28. And so that's going to equal to 11.2 meters. The answers are exactly 4 times as big as the original height. The digits in the factors are the same, and the number of decimal places in the product is equal to the sum of the decimal places in the factors. Okay, let's look at the next page. So in this lesson, let's think about how we can add, subtract, and multiply with decimals. Look at example 1. We're going to add decimals. Kim and Martin swam 50 meters. Martin took 0.26 seconds longer than Kim. What was Martin's time in the race? So they are swimming together, they're racing. They look like they're fairly close to each other, but Kim goes in first. So Kim finishes in 50.9 seconds, and Martin's time is 0.26 seconds longer. So 0.26 seconds after Kim finishes, Martin finishes too. So in order to figure out the time for Martin, you have to first know the important information. They're swimming 50 meters, okay? And you know Martin took 0.26 seconds longer than Kim, and Kim's time is 50.9 seconds. So from 50.9 seconds, you're going to add 0.26 to get Martin's final time. So 51 plus 0.3 is an estimate here. Estimate means you're going to round up or down to a compatible number. So 50.9 is close to 51, 0.26 is close to 0.3, and you're going to add them to get 51.3, this process is just for you to think, okay, my answer is around 51.3. So if I solve for an exact answer and it is way far than 51.3, then I probably did something wrong, right? So this process is for you to know where your answer is approximately at. So now we're gonna find the sum exactly. 50.9 plus 0.26. You're gonna add them all up, but you have to annex a 0. Annex means add. Add a 0, so each place has a digit because you want to line up the decimal places. If you look at the decimal point, they have to line up when you're adding or subtracting. So you're adding the same place values. 0 and 6 here are both on the hundredths place of the decimal, so you can add them all up. 9 and 2 here are both on the tenths place of the decimal, so you can add those two. So 6 plus 0 is 6, 9 plus 2 is 1, and in the same way you add zeros and 5s, but 9 plus 2 is 11, so you have to put 1 up. So your answer should be 51.16 seconds. Martin swam the race in 51.16 seconds. The sum is close to the estimate 51.3, so our answer is reasonable. Okay, so just make sure that you annex a 0 when it's needed and you line up the place values before you add or subtract. Let's look at try it. Suppose that Martin finished the race 0.47 seconds after Kim. What was Martin's time in the race? Use an estimate to check that your answer is reasonable. So instead of 0.26, he finished the race 0.47 after Kim. So now figure out Martin's new time. See if you can do it by yourself. Pause the video and come back when you're ready for answer. Okay, are you ready? Yeah, so you're going to do the same thing. 50.9 plus 0.47 is what you're doing. You can annex 0 when needed. So 7 plus 0 is 7. 9 plus 4 is 13. You put 1 up. 1 plus 0 is 1. You put the decimal place here. And 5 plus 0 is 5. So 51.37 should be Martin's new time. 51.37 seconds. And if you have estimated it, you can probably say estimate 50.9 to 51 and 0.47 to 0.5 and get 51 plus 0.5 is equal to 51.5. Okay, so here, why did we estimate 0.26 to 0.3 instead of 0? Because 0 means no seconds, right? In this problem, our decimals are very precise, so you have to round up to the decimal place. So 0.26, you can round it up to 0.3 to the tenths place. Okay? Convince me. If Martin finished the race 0.267 seconds after Kim, you would need to add 0.267 to 50.9 to solve the problem, right? Yeah. How is adding 0.267 to 50.9 different from adding 0.26 to 50.9? Obviously, you're adding different numbers, right? Is 0.267 is 0.267 same as 0.26? No. they are very similar and they're very close to each other, but they're not the same. So when you add 0.267, you need to annex 2 zeros to 50.9. So each place has a digit. Okay? 267 has more decimal places than 26. Okay, let's look at the next example. Example 2, subtract decimals. Amy ran a race in 20.7 seconds. Katie finished the race 0.258 seconds before Amy. How long did it take Katie to run the race? So in this case, Katie finished before Amy, not after. So what does that tell you? It tells you that Katie's time is going to be less than Amy, correct? Yeah. So Amy, who ran 20.7 seconds, will be more than Katie's time. So the whole thing here in the bar diagram represents 20.7, and that's Amy's time. Katie finished it 0.258 faster before Amy, right? So you're going to subtract 0.258 from 20.7 to get Katie's time. Subtracting also works in the similar way. So 20.7 minus 0.258, you need to annex zeros at the end of 20.7 so that you can subtract 8 from 0 and 5 from 0. In this case, we're going to borrow tens from 0, which you can't. So you're going to borrow 10 again from 7, and then borrow 1 from that. And then you get 10 minus 8 is 2. And then 9 minus 5 is 4. 6 minus 2 is 4. And 20 minus 0 is 20. So Katie ran the race in 20.442 seconds. And if we have an estimate here, 20.7 minus 0.3 is equal to 20.4. Now, 0.258, when we estimate that, we need to think about compatible numbers. So mentally, what are easy numbers that you can subtract? 20.7 and 0.3 makes sense. So usually for decimals, you can round up to the tens place. Okay, let's look at try it. Suppose that Katie finished the race 0.13 seconds before Amy. What was Katie's time in the race? So now figure out the new time and use an estimate to check that your answer is readable. Okay, so pause the video again. You can work on it by yourself. See if you can solve it by yourself. Come back when you're ready for answer. Okay, are you ready? So instead of subtracting 0.258, we're going to subtract 0.13, and that's going to be 20.57 seconds. Okay, and estimation. You can estimate 20.7 into 21, or let's leave 20.7 as it is because we're going to round up the decimals into tens. So we're going to round 0.13 down because it's closer to 0.1 than it is to 0.2. So we're going to subtract 0.1, and that's going to be 20.6. And your answer is the estimation. This is the estimation. Our answer, 20.57, is close to 20.6, so the answer is reasonable. Okay, let's look at our last example, multiply decimals. What is the area of this and take map? Use the formula A, area equals length times width, to find the area of the map. So what is the length and what is the width here? Length is always the longer side. So this 3.25 is the length. Width is always the shorter side. 2.5 is the width. So in order to find the area of this thing, you need to multiply length times width. So 3.25 times 2.5 is what we're doing. When you multiply decimals, you do not necessarily have to line them up in decimal places, but you do have to count the decimal places. 3.25, count how many, has 2 decimal places. It is up to hundredths place. 2.5 has 1 decimal place, to the 10th place. So you would multiply these decimals as you would for whole numbers. 5 times 325 is 1,625. And 2 times 325 is 6,500. You would know how to do that with a whole number, right? You add them all up and you get 8,125. But then you counted the decimal places. And you're going to add the decimal places together and get 3 decimal places total. So from your answer, you're going to count 3 decimal places from the last digit. So from here, you're going to count 1, 2, 3. And you're going to put your decimal point right here after 8. So the area of the antique map is 8.125 feet square. Okay? So just remember to count the decimal places when you're multiplying and add them for the answer. Let's look at the try question. How do you determine where to place the decimal point in this product? The product is already given. How do you count the decimal place? You count the digit. You do not have to annex any zeros. You just count the digit. So 4.3 has 2 decimal places. So for example, if you have 0 in between, 0.403, for example, how many decimal places do you have? This would have 1, 2, 3. So in this case, if 0 is in between the digits, you count the 0 as well. This one has 3 decimal places. Okay? All right, 0.2 has 1 decimal place. And you add them all up, your answer should have 3 decimal places total. So counting from here, from your last digit, you're gonna go 1, 2, 3 decimal places to the left, but you're gonna annex a 0 in your answer if you need it. So when you multiply 43 times 2, you just get 2 digits, 8, 6, right? But you need to put 3 decimal places from 6. That means you need to add a 0 here, and you have to add a decimal place before 0. Is that clear? Okay, let's describe that in words. So start at the right of the product. We're going to move left the same number of decimal places in the product as the total number of decimal places in the 2 factors. Okay? Alright, that was how you could multiply decimals. Let's summarize our lesson in the next page. So to add decimals, you have to line up place values and add. You have to annex zeros and regroup as needed. To subtract decimals, also line up place values and subtract. You can borrow zeros from your previous place. To multiply decimals, you're going to multiply like you would whole numbers, but you have to count the decimal places. This has 2 decimal places and that has 1. And then you add the decimal places so that you have 3 decimal places from your last digit here. So you count from here, 1, 2, 3. And you do not cancel out the 0 when you have 0 at the end. After you add up your digits, 0 does count when you're counting the decimal point. Okay, that was lesson 1-1. If you have any questions, please ask Ms. King in class. Otherwise, we'll continue with the next lesson in the next video. Thanks for watching. Bye.